Today we're going to talk about bivariate data. Bivariate data are two quantitative variables. Let's take an example. The percentage saying they would vote for a woman president versus the year of the survey. What we're going to do is we're going to create a scatterplot. Now, scatterplot has two variables, the x and the y. For the x, I put the year, and you'll notice that it says year since 1900. So when you see the number 45 on the x-axis, that represents 1945. On the y-axis, I have the percent responding yes. So this would be an example of a scatterplot. Now we are trying to determine if there's a relationship or an association between the two variables. And based on the scatterplot, there seems to be an association that shows that as the years have passed, there's an increase in willingness to vote for a woman president. In other words, as the years increase, the percent increases as well. Now, when you're given two variables, you need to decide which one's going to be the explanatory or predictor variable, that's going to be on the x-axis, and which one's going to be the response variable, which will be on the y-axis. So let's take an example. Do students learn better with the amount of homework assigned? The question is, which one of the two variables is the explanatory and which one's the response? Now, in this particular example, the explanatory variable is the amount of homework assigned, whether it be in time or number of problems, and the response variable will be the student's score. In another example, does the weight of a car affect the miles per gallon that the car gets? In this example, the weight of the car will be the explanatory variable, and the miles per gallon that the car gets would be response variable. Are SAT math score and GPA related? In this particular example, it turns out you could look at this two different ways. You can say SAT math score would be the explanatory and GPA would be the response, or vice versa. GPA would be the explanatory and SAT math score would be the response. Is there an association between a person's speed and the amount of weight they can squat? In this example, the explanatory variable would be the amount of weight they can squat, and the y-axis or response variable will be the person's speed. What should you look for in a scatterplot? First thing you need to look at is direction. Next, form, and last, the strength. Direction. Which way are the points going? What you want to do is look at the dots on the scatterplot and look at what happens as x increases. In this first one, as x increases, you can see in general that the y's are increasing. In other words, if you were to draw a line that represents these dots, you would see that the line would have a positive slope. In the second example, you can see that if you were to draw a line that represents these dots, you would have a negative slope. And in the last example, you have a lot more scatter, so it would be really difficult to decide if you would have a positive or a negative sloped line. Next would be the form. Are the dots basically in a linear form, or are they quadratic, exponential, logarithmic? What you need to do is look at what generally the dots are doing, whether they're in a linear form, quadratic, exponential, and so on. Finally, strength. How much scatter is there in the plot? In the first example, you can see that there's a lot of scatter. If there is a lot of scatter, then what you have is a weak strength. In the second example, you can start to see a form being established here, so what you've got here is a moderate strength. And in the last example, you can see that the dots are pretty much linear, so we have a strong strength.